Okay, so we can continue with the next session. It's a great pleasure to welcome Ken on stage. So for those of you who don't know who Ken is, he's a Java pioneer, very knowledgeable, and he'll talk about something very interesting for many of us, and also something that's quite frustrating also for me, is how to teach properly Java and what you can do about it. So can you have the word?
There we go. Thank you all for coming. I'm curious how many of you currently are teaching Java, evening courses, full-time at your company? Okay, well that's cool. What we're going to talk about today is, as someone who's taught Java since probably 1999, and as it's evolved over the years, I had the good fortune of working in a school where we could evolve with the language, which sadly isn't always the case. And even after I've left, I've retired 4 years from the classroom, there's still new ways to deal with Java. Ooh, let me get my nice control. So, when I was at Dawson College in Montreal, and Dawson College treated computer science as a career. So for instance, in the same school, you would go to be a nurse. You'd go to be a manager for businesses. And we treated computer science as a practical topic. In 3 years, we made our students job ready. I think the term in most of the world is called an associate degree as opposed to a full undergraduate degree. And my specialty back then was the final year. I taught the major Java project courses. We would build an Outlook clone in pure Java, and then we'd build a complete e-commerce system 100% Java, even the front end. But that's for another story. I also teach at a local university where I started teaching C, C++, and eventually Java, primarily to students with little or no experience. So what we're going to look at is items that deal with, that's available now in Java 23 and 24. I'm hoping for 25 they'll be finalized. But when you consider that the vector library is in the 8th preview, I'm not quite sure when they're finally going to, solidify these changes. So a lot of the things you'll see here, you've got to use enable preview to make them happen. So first of all, let's begin with something simple. What is programming? Well, there's a few definitions, but when I'm teaching and what I've realized is the first thing students need to know is abstract data. You need to be able to model the problem. And that's difficult because students, they've taken your course because they want to write code, right? Maybe they've done it as a kid, they've got a Raspberry Pi, and code, code, code. That's all that's exciting to them. And you've got to get across to them, wait a minute, here's a problem. Well, what are you going to do? So for instance, I would use these as examples. My favorite, of course, is the one on the left, because that's the book I wrote. But I would give these to my students, and I would say, okay, model this. Right? Forget, we're not talking loops or anything. Just tell me, what's the title of the book? What would you consider that to be? The number of pages, the ISBN number, and so on. And these would be the first problems I would give to a student before we write any code whatsoever. And, as this is about the changes in the language, there's the traditional chart of primitive data types, right? I would have this slide up and I would lecture and, they would look at this list and go, huh? And then I realized there's just too much there. So I needed to shorten it a bit. And so these are the data types that I believe a beginner needs to know. And maybe the last one is iffy, but really, string, although we always use that as the last one, that's not really a primitive. It's probably the most important one to your students, because that means they can type anything in on a prompt. Int, long, short, really? Short to me is an advanced topic. Has anybody here ever actually used short? There's 3 or 4 of you. We'll talk about that later. Double, obviously. Again, float. Float is nice. Float shows up in Java graphics. But really, you got enough problems with the precision of double, you're not going to make it worse with float. Boolean, well, everybody wants true and false. But the new one I've added there is the local date time. Of course, you all know that you're forbidden from using the date class ever again, right? Why they won't kill it, I don't know. But if you're going to involve dealing with dates and that information, you want local date time. So with that information, I can take, for instance, the entry for my book, and this is how I teach my students how to aggregate data. No more Java beans. They'll come up. They're not terrible. There's still libraries that require all those sets and gets. But the reality is, and it's a word I don't like to use because it scares students, it's immutable, right? I save that for later on, right? And then all they think about is the X-Men and stuff like that. And, you know, I have to bring them back to what we're really doing. But this is how I would present it. Students would frequently look at the ISBN numbers, right? It's all numbers. Why isn't that an int or a long? Well, what I remind my students is, if you're not calculating with a numeric value, store it as a string. Because if you store it as a numeric, somebody on the team is going to decide, let's divide the ISBN by 2. You can't do that. So this is where I start now, right? Again, I've left the main in there. We'll understand why in a few moments, but it prevents errors from showing up. But records are the key today, right? Start records early in your presentations. So let's continue on. What is programming? Well, it's step-by-step problem solving. This is when we want to start writing code. Here is where my biggest struggle with students comes in that that's what they want to do. Here's a problem. I don't want to think about it. Quick, give me the keyboard. I'm going to write code. I need to encourage my students to actually write. Write me a page. Tell me what you plan to do, right? I don't care about the code yet. I want to know if you understand the problem, if you can tell me the steps. Now, some teachers may do this in the form of flowcharts. They're okay, but I really think if you get people to write things out in their natural language, French, English, Bulgarian, whatever, they think about what they're doing more thoroughly rather than just jumping to code. Here's a slide that I used years ago, and there were other slides, but I always like this one because this is the program that started my career as a software developer. In 1980, I bought myself an Apple II Plus. And I know I'm old because when I mention that to some of you here, you all go, what's that? All right, look it up. I didn't put a picture of it here. But I brought this thing home and I became obsessed with it. And in the 1980s, there were dozens of magazines dealing with computer programming. There were bookstores just about computer programming. I was working as a photographer at the time. But every night I come home from work and I would just type in every program I could find. And this was one of the first, and it's a silly thing, right? It's the classic guess a number from 1 to 10. It has, of course, the evil go-to in there. But really, it kind of works. And this was just so easy. I could do something interesting. But we evolved. I call that spaghetti code because you wrote as you thought. I need input, I need to evaluate it, I'm going to show the answer. It's actually not a bad structure to begin with. But then as we move on, yes, we talk about structured coding, object-oriented programming, though I have to admit I usually describe it as confusion-oriented programming. I really thought I was loud enough. I always get told I'm too loud. So object-oriented programming is confusion-oriented programming. Because when you're trying to explain to students classes and what you need and when you need a class, they're just scratching their head and going, I just want to write code. I don't want to organize it. Structured, I can get across, but I'm still having trouble having them understand that. So, do we really care when we're starting to teach somebody what the methodology is? Well, as I said, not at first, right? You want them to understand the problem. You want them to write it up. So whether it's spaghetti, right? You want to learn assembly language, or you found a basic interpreter somewhere, or structured or OOP, they're organizational decisions. They become part of what you will eventually do, but you don't want your students to get hung up on, it has to be OOP or structure or whatever. You'll find that it can come naturally. And of course, you can write really good code and you can write really bad code with either of these, any of these three methodologies. So why are we all interested in Java, right? In my career, I have programmed, well, BASIC, though I didn't make much money in that. I actually programmed in PL1. Does anybody here know what PL1 is? I thought so. It stands for Programming Language 1. It was invented by IBM for mainframes, and I used a version for the IBM PC in 1984. And I made a lot of money writing it, but it was a structured language. When you look at C, and you look at many other structured languages that came out of that period, they're all related to PL1. But that was a specific project, and from there, I started writing professionally in C, in Pascal, and these were structured. It meant that you have to consider what are the tasks that you're doing. And then we got to Java, and I got excited about Java because for the first time you had standard libraries for exciting things you needed to do. But the only thing I could ever do in C or C++ was scanf and printf, right? And then try and figure out what other library, I want to do a GUI, oh geez, forget that, right? There's no standards there. And suddenly Java had all these amazing standards. So we liked it because it was more object-oriented than C++. Would you really let your children learn C++? I certainly wouldn't let mine. That massive set of standard libraries that I mentioned. The numerous tooling options. You know, back in the day, if you were doing C, C++, well, if you were someone who hated themselves, you used VI. Or you got a Windows machine and you used Microsoft C. I worked for a number of years writing C software for Linux that I used to write under Windows and then copy it to the Linux box because I didn't like the editors in Linux. But that was just me being strange. Write once, run anywhere. The classic cliche, but it is exciting. It means that you don't care what computer you're on. In my program at Dawson, we transformed ourselves from a COBOL school to a Java school. And in making that decision, C# was the other contender, but we realized if we had C#, we were going to have to force Windows on everyone. Now, quite frankly, I'm a Windows fanboy, so it wouldn't have bothered me. But I knew our students had Macs. I think in my 31 years, I only ever had one student who admitted to having Linux on their home computer. Right? That I thought was interesting. I thought more of them would. But now, you're no longer thinking about the machine. You're only concerned with the JVM. And of course, all the different platforms it, well, used to run on. I remember my first cell phone actually had Java, so I could play Snake on it. That was exciting for 3 or 4 minutes. But then things happened to the world of Java. It suddenly became unfriendly, less popular. First of all, I was looking at the latest download from Adoptium, and it's 354 megabytes. Now, high-speed internet and everything else, but you look at students today and, they don't have a sense of going to a special website. They go to the store, right? Let me download from the store. Java has evolved amazingly over the years, but what I've perceived is the evolution has been to service the senior developer, advanced systems. I'll show you a brief example of streams, and streams are really exciting. And then I read the article where somebody actually used the JMH to measure the performance of strings. They're about 100 times slower than a loop. But they're cool, right? They're professional. And then there's that lambda word. The excessive boilerplate. And then, of course, there are the terminology that we're all supposed to know. Orientation. Wait a minute, I thought there was a problem with that in the US. I'm sorry. Polymorphism, inheritance, mutable, immutable. And then the last one, I just mentioned it, stream. Why does it care how I pee, right? What's my stream? No. Right? It's just not fun anymore. So let's take a look at what has changed that I believe can bring some of the fun back to Java. So here we go. Here's the classic first program that every book has. As a Canadian, of course, I won't say hello world. I'll say hello moose, right? And I remember standing in front of students in their first class and saying, okay, let's take a look at what's in these 1, 2, 3, 4, 5 lines. There's this public thing, then there's class. I'm not going to tell you about that. Hello, or opening brace, what the heck's that? More public, static. Do I have to use a fabric softener when I'm coding here? I don't know. Void again, main, string, square brackets, args. Oh, another one of those bracey things. System, and then out, and then print line. And then finally, the string thing, a semicolon. I mean, it's endless. In those few lines of code, all the stuff that's there that I have to tell my students, just ignore that, right? Look at the print line. Isn't that nice? Look, you've written your first program. What? So public class, that has to do with that class thingy, right? That you're telling your students to deal with. Access control, that sounds ominous. What type of object? Wait a minute, there's more than one, right? There's a class, there's an interface, there's a record. I've probably left out some. There's probably somebody inventing one right now. And so I would find myself in a classroom telling the students, just ignore that. We'll get to it. Eventually, you'll learn what that's about. Or how about in the code? 6 pieces of information to print the word hello moose. Access control again. Object or no object. That's static. Return types. Method names. Parameter types, it just goes on, and parameter name. And again, I say, ignore all of that, right? You can copy it, it'll run, you'll be happy. Eventually, we'll get to that. But I knew it bothered them. What was I hiding from them? What was I keeping from them such that I wouldn't tell them what this was about? And then in September 2022, Brian Getz, you should probably all know his name. He's one of the chief developers of the Java language. someone who has told me off numerous times, but that's okay. He wrote this amazing design note calling for an overhaul called Project Amber. For the first time, a serious look at simplifying the language. And that simplification comes from the fact that if you always have to write system.out.println, why the hell do you have to keep writing system.out? It finally got through. So, a main method that makes sense. JEP 495, simple source files and instance main methods, still in preview, but let's take a look at the signature for main. It's just void main. And this is not just, if you're doing a Project Amber project, this is now allowed in any Java application. You still got to do enable preview, but you can take your classic Java application that doesn't have any parameters at the command line, and you can get rid of that public static void blah, 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 and just put in void main. The JVM has finally figured out all that other crap that you always had to write. You don't have to write it anymore. Hooray! And then how about the message? Finally, system.out is gone. It's over. It's the end. And again, can be used in regular Java. There's even, my favorite is read and read line, where you can include the prompt in the request. We'll see that in a moment. Fireworks, I'm excited. And now for something completely different. Say hello to the classless class. There you go. There is a complete, and I'm sure you've all seen this, there is a complete Java program. You can run it from the command line. If your IDE has an enable preview, it'll run in that as well. No imports, no decorations. Now, we know what it really is. It still is public static void. There's still a system.out.println sneaking into the bytecode. That hasn't disappeared, but finally a recognition that we don't have to keep writing this. We don't have to have our students write things that don't make sense to us. The next thing, next change, if we take this classless, is what's called the tolerant launch protocol. So we all, if you've ever done command line, you normally say Java C first.java, and then you say Java first, and it executes. Heaven forbid there's more than one class, because then you got to say Java C for each one of them. There was a quick change that allowed you to say Java, the name of the source file, it would compile and run. That's actually been around for a few revisions. But the big change is if first.java has an import for another Java file in the same package, or actually the package would be there, it'll compile those as well. It's kind of a mini build system for the first time. At this point, we've talked about data, we've seen the simplified, they've all done hello world. We can start talking about the good stuff. Sequence logic, sequential flow, selection logic, conditional flow. We're going to see some of those soon. Iteration logic, count control. Those are the classic terms that you see in every textbook. So how do you teach logic and syntax? Well, in my belief, it's examples. Try and stand in front of a student and give an in-depth presentation on a for loop. Right? Half will go to sleep and the other half will be checking their phone. You got to make them start writing code, and code you're giving them. Give them examples. And then get them to change the examples. Make it their own. And make sure that all your examples are available to them. So, we want our students to write their first program, the program that's going to get them a job. Here we go. You want to get a job at the Canadian Space Agency? There you go. Your complete program. All that decoration stuff is gone. It's just the logic, right? There's a for loop, a nice print line, blast off, and to run it, well, now I've got to add that enable preview. I'm hoping to see that go away shortly. Remember this game from earlier, my spaghetti version? There it is again. So I decided, or I used to show this in what I would call pure object-oriented Java. I've actually shortened it a bit. So there it is, 27 lines of code to play this game. I have a longer version where I put the secret number and the guess number in a Java bean. Then I could get it up to like 35 lines of code. And it's like, really? Heck, I'm even a purist. Let's see, does the laser work on this thing? There it is. We can't see it. I even do a system.exit. I don't much anymore, but there are reasons for it. Another presentation. So, of course, people come back to me and say, oh, hey, we don't like Java because Python is so much easier. I actually asked an AI to write this for me. I do a little Python, but not enough. And so this is what came out, and it's perfectly good code. There's nothing wrong with it. I still don't understand what happened to the SE in there, but every time I read that, I read elf, not elif. But I'll have to deal with it. So people will say, look, 10 lines. You just did it in 27 in Java. Well, here it is in 10 lines in Java. It's actually fewer lines because we have those braces at the beginning and the end. It's the same idea. It's the same program. It's not perfect. That integer.parseInt bothers me. I don't quite understand in Python by casting. It converts it into an integer, but we're getting there, right? I'll needle Brian some more. But there you go. This idea that Java is complex, is difficult, that's ancient history. So what's going on here? There are two imports that you don't see in classless Java. And they are the import module java.base. How many of you have seen this? Oh, wow. You don't know what you're missing. Imagine that you could have an import that would bring in the 20 or so most significant Java libraries, collections, streams, file I/O, all the good stuff. And you just need one import. The static io.io, that's what gives us the print line, the print, the read line, and the read. So let me talk about some other ideas about teaching Java to students today. I'm going to talk about the switch. I'm going to complain about the switch. I'm going to complain about if. I'm going to complain about imports. So the first thing is you have to stop teaching and using, I'm exaggerating here, but I still consider it the 17th century switch. Right? Java switch is identical to the C switch. I know why it's written that way. It has to do with the machine language of the CPU and the way it handles comparisons. But really, we've all seen this kind of code. Break, 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 break. You know, they tell us how goto is evil. We should never use goto. And so what does Java have? You know, Java has two go-to commands, break and continue. They're absolute go-tos. Wait a minute, they said they were bad. There's no need for this anymore. There it is in the 21st century. Now, the switch now comes in expression or statement. The difference is statement doesn't return a value. So instead of putting a value there, you could call methods, put in braces, do everything you used to do in a switch. And this is my favorite, is the expression where it returns a value. Right? If I go back for a moment, I don't have to keep repeating. What's the principle? DRY, don't repeat yourself. The switch is all about repeating yourself. And now it's gone. It's over. And I can certainly explain that to a student far easier than I can explain the first case and the need for the break. And of course, students are going to forget the break. And then they're going to get results they don't expect. And then they're going to put up their hand. And I'm going to have to run over there and go, you forgot the break. No, you don't have to anymore. Or how about this one? To me, we're going to see the most exciting advance in the switch. I'll make a strange remark. I used to program in Visual Basic 6. I made a few bucks. VBA is still based on that. And it had a select case that was brilliant. We'll see it in a moment. So here we go. I want to check a range of numbers. So it's the old if, else, if, else, if, else, if, else, and on and on and on. And then we can print the answer at the end. Again, why? If anything, this should be a switch, shouldn't it? But of course, switches only test for equality. Are you equal to it? Well, not anymore. So we're going to see two new versions. The first version that came out, I think around 22 or 23, was the pattern matching switch. In this case, and this is an example of halfway there, by the way, but it's an interesting value. I can switch on an object, not an integer, and my case simply looks to see if case integer, that is an integer. But you can imagine it could be anything. Once it's made a match, we come to the when clause. And the when clause allows me to do what Visual Basic 6 allowed me to do forever. Do any kind of test I want. I'm not just restricted to equality. Here I'm doing if I is greater than or equal to 100 or I is less than 200. Now this is an integer, so it handles the conversion automatically. But if this were an ordinary class, I could be calling methods. As long as the method returns a value, then I can use it in my test. So I can use this with Java beans if I want to, with records, whatever works. And I print it out. But of course, when everybody saw that, they went, but what about primitives? And now we have the primitive switch. So now I can say int I. I don't have to wrap it in an object to make this magic work. And when it fails in a when clause, it just goes to the next case. Didn't mention that before, but that's how it's working. So the when is actually the determinant of have we made a match yet, as opposed to the type. So the pattern matching says, we can pattern match on an int. Well, we can pattern match now on floats and doubles. A little scary. Make sure you're doing between ranges and not absolute values there. But all that is possible to us. And again, this is something, well, to me, it still makes more sense than if, else, if, else, if, else, if, or the old switch where I couldn't even do this anyways. Ooh, I dropped that out because you can't have a presentation unless you see real code. So let's look at some real code. So I was doing a presentation on Java best practices. I presented it to a Java user group in Riyadh, Saudi Arabia, online. I told them I'd come if they paid, and they smiled and said no. But in writing this, the purpose of this was to demonstrate the difference between using a loop to read a file as compared to using a stream. And as you can see, the stream is smaller, and there's other things, but that's not the point I want to make. The point I want to make is what I needed to write up top there. I needed to import the buffered reader, the file reader, the I/O exception. Oh, I want to use the logger, so I got to get the logger and the logger level, and NIO files, NIO path, util stream Java. You want to know why your students drop your course and go take Python? That's probably one of the main reasons. And it's all great that the IDE will tell you that this is happening. Cool, but that doesn't make it any easier to understand. Whoops. Wake up, computer. So let's look at the newer version. So here's the exact same code. I've jumped right to classless Java. So I do have one import, but notice just one. The Java logging module. This takes care of system logging and takes care of levels. All the others, the buffered reader isn't necessary because the default import is java.base. And so they're all there. And so now I can talk about the code. So I have this computer that if I walk away from it, it has a tendency to save battery power, even though it's plugged in. So I will stand here now. I won't leave it. I think PowerPoint keeps it from happening, but not my IDE. But again, you can see, if I'm standing in front of a class, I'm talking about how I'm reading lines from a file. I'm not having to explain all those imports. Oops. Come on. So that's where this came in. Now, on the left is what I needed. Now, on the right, so let's imagine that I still want to write this in classical Java, right? That I still want to, have public class. What imports do I need? Well, then I need to be explicit in the imports. The trigger for the implied imports is when you just write void main and write your code. Then you don't need Java base or Java IO. But if I were doing this in a standard Java program, I just need those three. And if I'm not a very good teacher and don't teach logging, I can get away with only two and have everybody write system.out. Oh, no print lines for checking. But again, look at the simplicity here that we didn't have before. So some other points. Get your students to use a logger early, right? It's really easy. I'm sure all of you write a logger and put into, shouldn't go dark in here, you write name of the class, .get name. Well, I did that forever, and then for the first time I asked myself, why am I doing that? If I look at the Java docs for get logger, it just wants a string. So just write a string. If I've got to copy the name of the class so that I'll get the name, why don't I just copy the name of the class and put it inside of quotation marks so it doesn't have to generate the logger from it? And then there I go, level info and so on. Now again, we're using the system logger. I haven't played with this with SLF for J or the other loggers, but when we're starting off, it's important to me at least that my students understand the difference between user interface and developer information. They're two different things. The logger makes it clear that the output is information of significance to the developer and not to the person who might be using the application. At this point in my course, now I can start getting theoretical. So when we talk about methods, we all know the solid principles. I have two that I'm most fond of. The first is single responsibility. When a student gives me code, I will actually look at every single method and count all the things it does. Now, I make it clear the goal is one. It's never possible. And sometimes it becomes excessive when it is. Many years ago, I taught C to a company that wrote software for satellites. And they wrote it in Fortran, and every method in Fortran was a separate file. The application was tens of thousands of files long. It was like, oh my, ooh, ooh, ooh. But that ensured for them the single responsibility principle. So look at your code. How many unique tasks is it doing? Now you've got to talk about classes. Here's where separation of concern comes in. This has to be on their mind. I'm writing a class that's part of the user interface. I'm writing a class that's a business process. To use from Ghostbusters, I'm avoiding crossing the streams. I'm keeping it independent. Whoops. Oh yes, here we go. I hadn't realized it was there. Then, of course, there's the most widely used pattern in software development. It's the stream of consciousness pattern, where you just write things as you think about them. Right? Going back to when I said my students have to write a paper on what they're going to code, so that I can identify that they're doing this and they haven't organized it in any way. So stream of consciousness. Thankfully, people don't write books about it, but people still do it. We're just about the end here. Unit testing. I'm visiting the chairperson of a computer science program at a university in Montreal. I won't mention that it's Concordia. And as we're talking to the chairperson, and that's somebody I've known over the years, the first thing we asked them, so this was 2 years ago, we said, what version of Java do you have in your program? And they're a Java university, in that's their primary language. And he proudly told me they were using Java 8. And he continued to say, there'll never be a need for anything else. Okay, Java 8 was significant, but other things have happened. But okay, we can deal with that. And then I asked them the question that blew me away. I said, when do you teach unit testing? Right? We taught it at Dawson in the second year of a 3-year program. This unnamed university proudly told me that it is offered in one master's program, and they have 6 of them in computer science, but only one of them, software engineering, gets 1 course in unit testing. They don't see it at the undergraduate level, and 5 out of 6 computer options like application development or web development, they never get shown unit testing. Really? Unit testing, if it's not your first course, it can't be any later than the second course, right? I would have my students, when they would submit work to me, they had to submit the unit tests. And the first thing I would do is run the test suite. And if I didn't like the results, I'd send it back. I'm not even going to look at your code, right? I need better test coverage. I need a better range. You can't just test for things that work. You have to test for things that won't work. And only when the unit tests are sufficient, based on their level, obviously if it's a first level course, it's not going to be quite as extensive, only then will I look at their code and comment on it. I should point out that when I return code like that, there's no loss of marks or anything, right? I don't want to depress them. I have other ways of doing that. I want them to become successful. So do unit testing early. And then there's the question of build systems. Again, maybe not a first one, but eventually you're going to want to use things that aren't in java.base, aren't in the JVM. And regardless of the IDE you use, trying to figure out how to add libraries to the class path or where to stick them in IntelliJ or NetBeans or Eclipse or whatever, there's a whole course in that. I'm a fan of Maven, and Maven can be quite simple. You don't have to get into all the profiles and the build plugins and everything. Default is fine. But for instance, I don't teach Swing anymore. It's archaic. I like JavaFX. That's when I typically bring Maven into the mix. Few lines of Maven code, and they're all set to go. And again, unit testing. So, some final thoughts here. Use an IDE early. Maybe not on day one. You don't want to overwhelm them. But by the end of that first introduction to Java, they should be using an IDE. There's no denying how useful it is. Things are getting more exciting about AI, but I get to talk about that tomorrow at the end of the day. Comments. I once contributed to a project. I'm telling stories. And I was giving a sample of some code for the example section. And as a teacher, the best way to describe what I do is I comment excessively. So I submit this code because it's meant to be an example. It's not part of the open source project directly. It's an example of how you'd use it. And I submit it to the group, and they send it back to me saying, we can't accept this. And I go, why not? They said, well, we don't mind the fact that you put comments in the Java code, but we still think you put too many. But you put comments in an HTML file. That's just not done. And I went, what? And even worse, I put comments in a POM file. Well, this was grounds for them to revoke my programmer's license. I had to remove all the comments before they would accept it in the project. I never submitted again to them, and that code is long gone from that project. But I could not believe the hatred for comments. It's all nice to say we should write code that is self-documenting, right? I sometimes say, you should be able to stand out on a street corner and read code out loud, and anybody walking by should know what you're doing. Well, that's not going to happen. And because of that, you need to comment. I say use the Java docs style. You don't have, I had one teacher once in my program who taught their students to comment every single line of code. Those students hated this woman. She was a brilliant programmer, but it was ridiculous. At the very least, you comment every method, every class. And I don't care about access control, right? Java docs, the tool, will only pick up the public methods, but I still require my students to comment every method in that style. Private, protected, the whole family there. And then finally, my last thought for today, and I'm just about out of time, is have fun teaching. When I was a young man, I wanted to be a singer, and then I discovered I can't sing. Then I wanted to be an actor, and I discovered I couldn't act. And then I wanted to be a dancer. And actually, that was iffy there. It could have been a direction I went, but I was smart enough to realize I couldn't. And as I went through a number of careers, when I finally got into the classroom, I finally got that performance fix. And that's why I love to come here, right? I have fun. And if you have fun in front of your students, they're going to sense that, and they're going to enjoy what they're doing. So, thank you all for coming. I'm around if you have any questions or anything, and have a great rest of the conference.